to the Lathisms podcast. I'm your host, Evelyn Lamb. In each episode, we invite a Hispanic or Latinx mathematician to share their journey in mathematics. Today, I'm very happy to be talking with Enrique Trevino. Hi, how are you today?
Very good. Thank you for having me here.
Can you tell us a little bit about yourself?
Yes, my name is Enrique Trevino and I'm from Ciudad Juárez, Mexico. Well, I grew up in the border between Juárez and El Paso, and so I studied before undergrad in Mexico and then undergrad in the US. I studied in the University of Texas at El Paso while still living in Juárez. So I've crossed the border over 1,000 times, and I did my PhD at Dartmouth College. My area of specialization is number theory. I then worked 2 years in Swarthmore, and then I've been at Lake Forest College for the last 6 years.
Nice. And maybe we can jump right into your research. So you say you specialize in number theory. What kinds of questions in number theory really excite you?
So I really like questions that are easy to understand. A lot of my papers concern what's called as the least quadratic non-residue. So when I was in high school, my first eye-opening experience was finding out that the sequence 2, 5, 8, 11, 14, and so on, where the difference between consecutive elements is 3, that sequence does not contain any perfect squares. And I was really inspired by this when I saw the proof. It's a very simple proof using congruences modulo 3.
Wow, I'm sitting here thinking, like, really? Is that really true? I didn't know this fact. I'm going to sit down later and try to write down and see if I can prove it wrong.
Yes, it's pretty simple. So if x is, well, maybe you wanted to prove it yourself, so I won't spoil it. Or should I?
You could go ahead, yeah. Dear listeners, if you don't want the spoiler, just skip forward 15 seconds.
Okay, so if x is 0 mod 3, then x squared is 0. If x is 1 mod 3, then x squared is 1. If x is 2 mod 3, then x squared is 4, which is 1. So you always get 0, 1, you never get 2 mod 3.
Oh, okay. I guess I won't try to prove it wrong. I'm pretty convinced to this point.
So then we say that 2 is not a quadratic residue mod 3 because of this property. So if you pick a prime p, then there are some remainders that can be squares and some that cannot be squares. They're actually spread equally. If you avoid 0, then the rest, half of them are quadratic residues and half of them are not. So an interesting problem is which one is the least quadratic non-residue. And that's something I've written a lot about.
And so that means, like, given a prime p, you're looking for what the smallest number is for that prime that isn't a quadratic residue mod p.
Correct. So for example, if you take the prime 7, then the smallest quadratic non-residue is 3. So 1 is obviously a quadratic residue because 1 squared is 1. And 2 modulo 7 is a quadratic residue because 3 squared is 9, which is 2 mod 7. So the first one that is not is 3 mod 7.
And I suppose one natural question would be whether there's a pattern to which numbers are these least quadratic residues. Is that correct?
That is a nice question. And if you just fix, so always the least quadratic non-residue is a prime. That's because this thing is multiplicative. So if you multiply two residues, you get a residue. If you multiply two non-residues, you get a residue. So it's kind of like a parity thing. It forces the least one to be prime. And then suppose you say, well, I want the least quadratic non-residue to be 5. What do the primes have to satisfy? So then you can use something called quadratic reciprocity, which was Gauss's favorite theorem, and figure out what remainders would work. So what properties does a prime have to have so that its least quadratic non-residue is 5? You can answer that precisely, but what I usually study is how big can the least quadratic non-residue be. So that is harder because it's a little more broad.
And so is it known that it could be arbitrarily large, or is that not the case?
It can be arbitrarily large. So the question is, how large with respect to p?
Right. Okay.
So for example, there's a nice proof that it's less than, say, square root of p plus 1. But how small can you get it? And if you think about it probabilistically, like if you model by saying, okay, we'll just flip a coin and decide if a number is a residue or a non-residue, then this suggests, if you do some probability, that the bound should be like log times log log. So very small. But what we can actually prove is nowhere near that good. It's something like p to the 1/6.
Okay. So, yeah, that's a lot of interesting questions for our listeners to think about. But backing up many years, how did you get interested in math?
So I was always pretty good at math at school. Like I liked to be the fastest when we were in elementary school. But then what really got me very interested was the mathematical Olympiad. So when I was a junior or maybe a sophomore in high school, someone invited me to go to these special like training sessions for math competitions. And that's where I found out this property that 2, 5, 8 never has a square. And I really fell in love with math at the moment. So I always knew it was good at math, but I didn't realize that math had this incredibly creative side, and that it was something so exciting. So I always was good at it, but I didn't know how interesting the field was until I was exposed to it in the Math Olympiad.
And you competed then for Mexico?
Well, it depends what you count as competing. So, so the Mexican Math Olympiad, each state, there's 32 states in Mexico. Although when I was in high school, there were 31 states and district of the federal district. Each state sends 6 people to the competition, and I was one of the 6 from Chihuahua. And then in this competition, they select the best 16 in the country. I managed to pass that threshold as well in my senior year in high school. But then out of those 16, they train us for months, and then they select the best 6 for the International Math Olympiad, and I was ranked 10th. So I didn't make that final cut.
But the experience sounds like it was a pretty positive one for you anyway.
Oh, it was extremely positive, and now I'm extremely involved with it. Just last month, I was at the Ibero Math Olympiad as the leader of the Mexican team. So I've been training students for competition since 2004.
Do you feel like once you sort of saw this creative side of math through being in the Olympiad, do you think that's what really, do you think at that point you knew you wanted to be a mathematician?
So when I was in high school, I loved programming. So I started programming when I was in 5th grade, and I loved solving puzzles with respect to programming. So I thought I wanted to be a programmer, and the Math Olympiad made me consider math as a alternative possibility. So when I started undergrad, I was a math and a computer science major. And in my computer science classes, I realized that the only thing I liked was programming. I didn't like any of the other stuff. And most of what I liked was already in math. So I ended up just graduating with a math major and a CS minor.
And did you go to grad school directly from that?
Yes, I went straight to grad school.
Were you encouraged by your math professors at UTEP to pursue math as a career and to pursue grad school?
Yes, I was. So I started actually not at UTEP. I started at another institution, and I missed home, so I transferred back to live home.
Okay.
And so my dad was not in favor of me transferring. He thought I was changing to a weaker school. So I had to like convince myself that there were good reasons for the change. So I changed from a liberal arts college to a bigger college. One of the reasons I thought was, well, I can take graduate classes and I can be very involved with the Mexican Math Olympiad if I live at home. So immediately as a sophomore, I started taking grad classes. So I took Galois theory. The first fall I was at UTEP, I was a sophomore. And the professor thought I was very good, so he immediately encouraged me to apply to a scholarship. And then I got a nice scholarship. So, yeah, I guess he was very encouraging. And then this professor wrote letters of recommendation when I was applying to grad school.
How was the transition from college to grad school, especially moving such a far distance away from your family?
Well, it was easy for me. I like traveling a lot and I like new experiences. When I was an undergrad, I studied abroad in Budapest. So I guess this kind of sounds contradictory in the sense that I moved back because I missed home in undergrad and then it was easy in grad school. But I guess something changed in those 3 years. I loved my experiences in grad school and I loved experiencing snow for the first time. Well, sort of the first time. It does snow in Juarez, but not 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 the whole winter.
Right.
Just one or two snows. Yeah. So the change was not too difficult. I think because of the Math Olympiad, I had been traveling a lot in Mexico to take students to competitions, and I was very aware of math in different locations, and I loved the graduate school vibe. I loved being independent. Yeah, I really enjoyed the transition.
And I'd imagine, it sounds like you had a really wonderful time there, but there are always challenges in any career, whether at grad school or when you're applying for jobs or anything. How have you dealt with challenges like that in your career?
Yes, for example, I had a sort of a serious challenge in my second year in grad school when maybe I interpreted the rules a little differently than the the professors there, but I thought the classes were optional, so I took a summer job to work doing research with undergrads at Trinity University, and the university wanted me to take a algebraic topology class. So they took away my stipend for a summer, and I was very upset about it. But I decided to, I was a little stubborn, so then I decided to prove them wrong that this was a bad decision. I still worked in Trinity, and then I learned algebraic topology on my own, and then my goal was to be the first to finish the quals, and I succeeded in my goal by like 2 days. But I just wanted to prove them wrong, that they shouldn't have taken the stipend, that I was correct in doing research over the summer, and that I could learn on my own. So I think usually in these cases, I try to prove people wrong if they think I'm not good enough for something.
Yeah. Well, and something I've enjoyed talking about with many of the people on this podcast is the importance of mentoring in their careers. Do you have people earlier in your career that you really consider good mentors?
Yes, certainly I have many. So in the Math Olympiad, there's David Cosillo. He's the person that taught me this 258 thing I mentioned, and he was very influential in me being in the Math Olympiad. And essentially, I went into math because of his lessons. He's still a very good friend of mine, and we worked together as coaches for over a decade. At UTEP, Professor Wojciechowski was really encouraging, and he gave me that nice scholarship. And then he would always, whenever he would see an opportunity, he would tell me about it. And in grad school, my advisor was excellent. I think he's an extremely kind person and very patient with me. So it was a great experience, and He's been very supportive, found great problems for me, and pointed me in the right direction multiple times. So yeah, I'm very grateful to them.
What are some of the things you try to think about when you are mentoring other people?
Well, many times I guess I think of what would I have liked to have heard. But usually my go-to thing is to listen to what the student really wants and try to see how I can help them achieve that. I try to be very kind and like sometimes, for example, Budapest was a great experience for me, so I try to tell my students about that opportunity. I also like to take them to conferences whenever I can, which is usually the Illinois Math Sectional from the MAA. And I meet weekly with students for Putnam problems, and we talk about other things like grad school, etc. But yes, usually it's just listen to what kind of things they want, and if I can help them, then help them. Sometimes I don't know about, because I went straight from undergrad to grad school, I don't really know much about the world outside academia, so I have to point them in other directions if that's the help they need.
Right. Yeah, I know a lot of academics can have trouble advising students who are going to non-academic paths.
Yeah, luckily I have colleagues that have been outside academia more than me, and it's easy to just point them in their direction.
And do you have any advice that you would give to math students who are thinking about how to decide whether to pursue a career in math?
I think loving the subject is very useful. Graduate school is not that easy if you're doing something you don't love. So perseverance is important, patience is very important. But I would think that loving the subject is key.
Well, thanks a lot for taking the time to talk with me this morning.
You're welcome.
Thank you for listening to the Lathisms podcast. It's produced by me, Evelyn Lamb, and made possible by a Tensor Summa grant from the Mathematical Association of America. Our music is Volvere by La Floresta. Lathisms is an initiative to celebrate the accomplishments of Hispanic and Latinx mathematicians. It was founded in 2016 by Alexander Diaz-Lopez, Pamela Harris, Alicia Prieto Langarica, and Gabriel Sosa. You can find more information about the project at lathisms.org. That's LATHISMS.org. Join us next time to hear from another inspiring mathematician.